In these two integrals, we have a U substitution inside integration by parts. So the first problem is the integral of x times e to the 2x divided by 1 plus 2x squared, right? That looks like a U substitution, but in fact it is not. We have to do integration by part first. The hardest thing is, so which one should the U be? This is really depends on your experience. So this one you should let the U be the top. U equals to x e to the 2x. Can you let U be the bottom? I haven't tried that. You can try and let me know. If that works, we will come up with the same answer. All right. So you let U equals to that, and then du equals to, wow, this one is a product rule. So we have one function times another function. Still remember the product rule? So let's do this in another color. So product rule. So we have f times g derivative that is equals to fg prime, right? Plus gf prime. Okay, let's apply the product rule. So that is fg prime. So that will be x times the derivative of e to the 2x is still e to the 2x. And then by chain rule, we have to take the derivative of the 2x that is equals to 2. And then we plus gf prime. So the g is just e to the 2x. The derivative of x is equals to 1, and then dx. So let's clean this up a little bit by factoring out a e to the 2x. So we have a 2x plus 1, and then dx. And then the dv, we haven't picked the denominator yet, right? So that will be 1 divided by 1 plus 2x. So 1 plus 2x squared dx, and then v is equal to the integral of that, 1 plus 2x squared dx. So this one you will have to do a U substitution. This one, the U substitution is not too obvious. So let's do a U substitution. So U substitution. I'm going to let U equals to, again, but this U has nothing to do with the U that we use in integration by parts. So the U substitution is only for this integral. We let U equals to the linear function 1 plus 2x, and then du is equals to 2 dx, and then the integral becomes the integral of 1 over 2, and then we have 1 over u squared du. All right, and then this is equals to 1/2, and then the integral of u to the negative 2. So we bring the negative down, and then negative 2 plus 1 is negative 1. And then that is equals to negative 1 over 2 times u, right? So that is 1 plus 2x. So that is the result. So the v is equal to 1 divided by, the negative, and then 2, and then 1 plus 2x. All right, and then we do the uv minus v du. And then we do uv minus the integral of v du. So uv is that will be negative uv, so that will be x e to the 2x on top, and then the bottom is 2 times 1 plus 2x, and then minus the integral of v du. So the integral of v is negative 1, and then 2, 1 plus 2x, that is the v, and then the du is e to the 2x, and then 2x plus 1 dx. We can simplify this, the 2x plus 1, the 1 plus 2x, that can be simplified, and then the negative 1 over 2, we can take this out. So we have negative x e to the 2x divided by 2 times 1 plus 2x, and then bring the 1/2 out. And then we have e to the 2x dx. Oh, this one is easy. Then that is negative x e to the 2x divided by 2, 1 plus 2x. This one, the integral of e to the 2x, that produce an extra negative 1, that produce an extra 1/2 in front of the e, right? So the 1/2 times 1/2 will be 1 over 4, e to the 2x plus c. If you quickly take the derivative of that, you will see why I put an extra 1/2 in front of it to multiply the other 1/2. So this is the answer to the first integral. Let's take a look at the inverse cosine. So the inverse cosine, the first look, it looks like there is nothing we can do. This one you can easily run into a mistake. So let's do the integral right here. So we have the integral inverse cosine x. Let's do a times 1 dx. That doesn't change the integrand anyway. So this one you can run into a mistake by doing this. So let's do the mistake in red. So if you let u equals to 1 and the du equals to 0 dx, and then v equals to no, not this, and then dv equals to inverse cosine dx. When you do the v is the integral of inverse cosine x dx. So this is the problem. So this is actually a mistake. This is the problem, right? You don't know how to integrate this. Then after one integration by parts, how do you came up with how to integrate inverse cosine right there? So this is a mistake. So that is not going to work. Then we have to let u be something else. Fine, let u be something else. So if you cannot pick the one, then you have to pick the inverse cosine x. So the derivative of inverse cosine, you study that in differential calculus. The derivative of inverse cosine is equals to -1 divided by the square root of 1 minus x squared. This is a formula. If you don't remember this, you have to look up the formulas either online or on your calculus book. And then the dv is 1 times dx because you already picked the cosine, and then the v is the integral of 1 that is equals to x, and then now we do the uv minus integral v du. So uv minus the integral of v du, that is x times inverse cosine of x minus the integral of v du. So that gives me a x times -1 and then the square root term dx. So the integral is a U-substitution. So this one is a U-substitution. So we have to let u equals to 1 minus x squared, and then du equals to -2x dx, and then you have -1 over 2x du equals to dx. So the x in the denominator will cancel with the blue x. And then we go back to our problem. So we have equals to x inverse cosine of x, and then we minus, so this is x, right? And then -1 divided by the square root of u, which is u to the 1/2, and then the dx becomes -1 over 2x du, because the dx, right? So you put this piece right here. And then you get rid of the x. So this x is gone, this x is gone. Check the integrand. This is in du, so there is no more x in the integrand. And then copy this one more time. And then we have a minus minus. So we still have a minus. So we have a minus 1/2, the integral of, this is a u to the -1/2 du. So u to the -1/2 du, that is 1/2 plus 1 is 1/2 plus -1/2 plus 1 is 1. So we have x inverse cosine x minus 1/2. So this is 1/2, right? -1/2 plus 1, and then the reciprocal, and then plus c. And then put the u back. The u is 1 plus x squared, right? So the 1 plus x squared, you are going to put this back here. So overall, you have x times inverse cosine x, and then minus, the 2 got cancelled, and then you have the square root of that. Either you keep that as a 1/2 or you keep that as a square root. So square root 1 minus x squared plus c. Oh, sometimes you can keep that as a 1/2 powers. Which one should you keep? You have to read the direction. If your instructor wants you to put things back to a square root, then you have to put it back to a square root. Alright, so that is the end of this problem, and it's also the end of this video. If you think I picked the best problem and provide you with the best explanation, let me know in the comment below. Like the video, share the video for me, subscribe to my channel if you haven't done so. Appreciate your help and support as always. See you all in the next video.